So this is part 2 of our review of roots of polynomials, and we're going to take some time over linear transformations. And we're going straight in with an exam question because it's the best way, I think, to explore this topic. This is the question from the 2018 Core Pure paper from Edexcel. This was an AS level paper because they only offered those that year. So just be aware of that when you're tackling questions. This is an AS equivalent, but this topic could appear at A-level standard as well, and it might look a little different, might look the same, but just be aware that there could be a difference. So we are dealing with a linear transformation of our roots. We know it's linear because we don't have any squaring, square rooting, or anything like that. We're just multiplying by coefficients and adding, subtracting coefficients. And we're told, without solving the equation, find the cubic equation. We know it's cubic because we've got 3 roots. Whose roots are these new versions of the old roots? So the first thing I do with a problem like this is find out what the original alpha, beta, gamma expressions were. So if you remember, you've got alpha plus beta plus gamma as something that you can figure out. Alpha beta plus beta gamma plus gamma alpha is something you can figure out. And alpha beta gamma as something that you can figure out. Now, the sum of the singles is minus b over a, the sum of the pairs is c over a, and the sum of the triples, of which we've only got 1, is minus d over a. So in the case of this first cubic, that is minus 3 over 1, so 3. B is minus 3, so minus b is positive 3, and a is 1. C over a is just 1. And minus d over a is minus 5. Now, there are 2 different methods that we can use to solve this problem. Method 1 is that we continue to persevere with our roots. And that's the one we're going to look at first. So I'm going to claim, and hopefully you agree with me, that if I add up my new roots, sorry, add, not multiply, if I add up my new roots, then I am going to get the expression for my new minus b over a, because the equations that we generated in the last video say that if you sum up your roots, you're going to get minus b over a. My roots this time look slightly different, but the sum of them should still be the new b over new a. Let's call it b prime over a prime, not because I'm differentiating or anything, but just to make them different from previously. But so this will represent the minus b over a coefficients in my new cubic, I'm trying to create. I'm now going to persevere with some of this algebra here. So I've got 2 alpha plus 2 beta plus 2 gamma plus 3. Hopefully everyone is happy with what I've done there. And now I should be able to factorize out 2. And interestingly, or perhaps not so interestingly, it leaves you with an expression for the original roots. So alpha plus beta plus gamma. Well, that's an expression we know the value of. The sum of my single roots is 3. So this is 2 lots of 3 plus 3. And hence the new minus b over a is 9. So bolstered by our current success, let's go for that for the second set. So this is new alpha and new beta, new gamma. So I'm just popping in the pairs here. New gamma, new alpha. That must equal new c over new a. So the product of pairs, no, that makes no sense. The sum of the pairs, try that again, must equal c over a. That's the same with our new roots as well. So again, let's persevere through some of that algebra. We've got 4 alpha beta plus 2 alpha plus 2 beta plus 1, and the same thing for my remaining expressions. I'm just expanding out these brackets in each case. I'm going to simplify, and I'm aiming again to find out some of the expressions I had previously. So sum of singles, sum of pairs, a triple perhaps, whatever pops out. Hopefully you can see we've got 4 lots of alpha beta plus beta gamma plus gamma alpha. And then 4 lots of alpha and 4 lots of beta and 4 lots of gamma and 3. Well, the sum of my pairs, that value originally was 1, and we've got that back, so that can go in. The sum of my singles, and then 3. And that totals up to a new C over A being 19. I can do that with the final one, exactly the same process. So put my new roots together, expand them out, search for the original expressions back in there, and that will equal new minus D over A. Turns out that what you get, just so if you're pausing this and working your way through it, is 8 lots of alpha, beta, gamma, plus 4 lots of your pairs, plus 2 lots of your singles, plus 1. And when you substitute in all of your values, that gives you that new minus D prime over A prime. So my new D over A is minus 29. Now, all I need to do is pull all these expressions together and whack them back into this equation that I've been given here, because I have now got the coefficients. We changed to W to notate a transformed cubic, so we must keep that W in there. So I've got minus B over A for my new expression being 9, C over A being 19, and minus D over A being minus 29. If we make A equal 1, that would give us B equaling minus 9, C equaling 19, and D equaling 29, and hence our new cubic is W cubed minus 9W squared plus 19W plus 29 equals 0. And you have to have that equals 0 on the end in order to pick up your final mark.